Welcome back, guys. In today's video, I'm going to be covering the concept of charge. So in this video, I'm going to be going over how to determine the charge of an atom based on where it is on the periodic table. So this is something that I actually found very tricky when I first learned chemistry. It seems like a straightforward concept, but a lot of students their first time kind of get tripped up with this. And once you learn this explanation, it's something that you'll never forget and something that you can apply when you're doing any problem. This is a very fundamental concept of chemistry. So this is my rough sketch of the periodic table. Obviously, not every atom is drawn, but these are some of the more common atoms that you are going to see. So to determine the charge of an atom on the periodic table, let's look at where it is on the table. So what you can do is you can break down the periodic table into columns, right? So we know that rows are, the atoms as they go across, right? But the columns are what we are more worried about when it comes to charge, right? So we can see the first column is going to include things like hydrogen, lithium, sodium, and potassium, right? There's a couple more down there. I'm not showing every single one. The second column is going to be beryllium, magnesium, and calcium. Then we're going to skip over the transition metals, right? So we're going to call this column 1, this column 2. We're going to skip over the transition metals, and we're going to pick back up when we get to boron, right? So boron is going to be the start of our third column. So this is going to be boron, aluminum, and so on and so forth, right? Then we go to the fourth, fifth, sixth, seventh, and eighth columns, right? It's going to have things like carbon and nitrogen, oxygen, fluorine, things like that, right? So once we've determined where something is on the periodic table based on the column that it's in, we can then determine its charge. Now, this is the explanation that you need to know on why something has the charge that it has. Now, this is all based on electrons, okay? Electrons are going to determine the charge that that atom has, right? So when we look at this final column of the table, right, these are called the noble gases. This is something that you should definitely know, right? It starts with helium up at the top, then neon, then argon. There's other ones like krypton in there. Xenon is another example of a noble gas, right? That's this last column, okay? Now, the noble gases have something called an octet, right? Meaning that they have 8 electrons making up their octet, right? Means that they are stable, right? They have a stable octet of electrons, right? That makes them happy. And actually, the charge of these other atoms is going to be based on the fact that they also want to become one of these noble gases in terms of having the octet. So that might seem confusing at first, but basically what we can think of is, let's say we have lithium, right? Lithium is thinking, what can I do electrons-wise to make it so I can have the same electron configuration, the same charge as one of these noble gases, right? So what we're going to do is we're going to say everything in the first column has a +1 charge. Now, why does that make sense? If you have a +1 charge, that means that you got rid of one of your electrons, right? We know that electrons have a minus charge associated with them, right? So if you're in that first column, what you're going to do is you're going to give up one of your electrons, right? And you gave up that negatively charged electron, right? Every time you give up an electron, you become more positively charged, right? So if you're hydrogen, lithium, sodium, potassium, right? What you want to do is you're going to give up one of your electrons. Give up one of your electrons to create a +1 charge. What that will do, right, if you're lithium over here, that will get rid of your electron and you'll actually have the same number of electrons as helium, this noble gas over here, right? And everything is kind of chasing this noble gas, this very stable octet of electrons that the noble gases have, right? So that's why lithium wants to do that. So let's look at something like magnesium, right? So magnesium and everything else in the second column is going to have a +2 charge, right? Why does that make sense? If I'm magnesium, I can give away 2 of my negatively charged electrons, right? That's going to make me have a +2 charge, right? I gave up 2 of my negative things, right? So now I'm +2 on my charge. So why would magnesium want to do that? Well, it knows if it gives up 2 electrons, once it gives up the first one, it will have the same number of electrons as sodium. Then if it gives up its second one, it's going to come over to neon and adopt that stable octet of electrons that this noble gas has, right? So we can continue to see this trend, right? boron and aluminum, they want to give up 3 electrons, right? So they're going to have a +3 charge, okay? Now if aluminum, right, gives up 3 electrons, it will go to magnesium, then to sodium, and then it can go all the way back to neon, right? So we can kind of get this trend. Now, things in the 4th column, it can go either way. They're 4 away this way and actually 4 away going reverse to the noble gases. So they can be plus or -4. It's not really a common problem to have to determine between that, so I kind of just skip over that. It can be plus or -4. Now, nitrogen, everything in that column, right, phosphorus included, is going to be -3, right? So we're not going to call this +5. Instead, we're closer to the noble gases this way now, so this will be -3. So why is that -3? If you gain 3 electrons, right? Remember, each electron is worth a -1 charge. So if you gain 3 electrons and get a -3 charge with those 3 electrons you just gained, look what happens to nitrogen, right? It can gain an oxygen, have the same number of electrons as oxygen, gain another one, have the same number of electrons as fluorine, but what it wants to do is gain that 3rd one to adopt that stable octet, 8 electrons that the noble gases have, right? Okay, oxygen is -2. Okay, so is sulfur, right? If they gain 2 electrons, they'll become their respective noble gases, and everything in here is -1, right? So these are called the halogens in this row. It's fluorine, chlorine, bromine, things of that nature, right? They want to gain 1 electron. They can become that stable noble gas, right? There will be more videos on electron configurations, but just as a rule of thumb, you can use this rule, +1, +2. We skip over the transition metals. They're a little bit more complicated. +3, plus or -4, right? And then -3, -2, -1. And the noble gases, right? They're happy the way they are. So let's determine the charge of the following atoms. So magnesium, right? It's in the 2nd column. It wants to be +2. So that way it can go to sodium and then, boom, to neon. So, right, this is going to be +2. Okay? Now, sulfur, right, is going to be in this row right here, this column, I should say. It's going to be -2 so that it can become argon. So this is -2. Marker's running out of ink here. Okay, and chlorine is going to be in this last row, so it's going to be -1. Okay, now, there's a very important question. I think this trips a lot of people up. It seems very straightforward, but it actually tripped me up and a lot of students that I teach up. So it says, why is magnesium chloride MgCl2? Okay, now let's think about this. Magnesium has a +2 charge, right? So magnesium, let's see if we can get a better marker here. Magnesium, right, has a +2 charge. +2. Chlorine has a -1 charge, which we'll write in red. Okay? So this is very important. When you combine 2 things, right? So if you're combining magnesium with this +2 and chlorine with this -1, what happens here is that these 2 things will give each other the charge, right? So this -1 will go here, and this +2 will go there. Okay, so that's why this is Mg, right? This gets the 1. The thing is, when it's a 1, you don't have to represent that. So you don't need to write Mg1Cl2. It's understood if there's nothing written that there's a 1. So this is Mgcl2 because of that +2 charge that we're going to give to chlorine, right? So it's really important that you understand why these things have the charge they do and why it's written the way it is based on the charge it has on the periodic table. So thank you for watching, and make sure to check out more of my videos on the channel.